Hello, marvelous Algebra 1 students, and welcome back to Topic 2, Linear Equations. As a reminder, last class we discussed how to find the slope of linear equations. Remember, linear equations has that hidden word line in there. We found the slope by first looking at the graph and counting. And then we learned the slope formula, that y2 minus y1 divided by x2 minus x1. And then we finished things off with a quick discussion of parallel and perpendicular lines. Today, we are going to cover a common equation form that our goal is to be able to graph quickly by the end of class. It's actually a form you might have heard before. It's one you're supposed to cover in 8th grade, slope-intercept form. So let's see what we can do. Most of this lesson is intended to be pretty self-paced, and I bet you'll be able to actually do a lot of it without my explaining how to do it. So if you want to work off ahead anytime, please feel welcome. So let's start. Miss Foley believes that the 4 points below are all generated by the equation y equals 2x plus 1. Prove that each point is or is not generated by the equation. Well, we need to remember that equations are made up of an input and an output, right? This x variable right here, the variable that has things happening to it being multiplied by 2 and added by 1, is our input. Sometimes that is called the independent variable, right? The independent variable is the variable that we get to choose what value it will take on. If I wanted to put a 7 in for x, we could do that, or an 80 into x, that's fine as well. After everything happens to the x, again being multiplied by 2 and added by 1, then we get an answer, which is sometimes known as the output. The output is the dependent variable. It depends on what we input or substituted in for x. So if we want to prove that these points are generated by the equation, then all we're going to do is we're going to take the inputs, the x's for each of these, and substitute them in for the x in the equation. All right. Well, let's continue through. And if you hear a loud chewing noise, it's because my dog decided to eat his breakfast at 6 p.m. All right. So we are going to start with our equation, y equals 2x plus 1. And we're going to go through and substitute. We're going to keep the y where it is, and we're going to replace the x with 3. Notice whenever we substitute, we use parentheses. Helps us keep from getting sloppy. 2 times 3 is 6. 6 plus 1 is 7. So I inputted 3, and I got an output of 7. And that matches the point here. That looks pretty good. All right, let's try another one. Now, something else you could do if you wanted to do this a different way, y equals 2x plus 1, is we could say, well, we are inputting negative 3 into this equation, and we are getting an output of 7. So we could actually substitute 7 in for y as well. And then we can work through and see what we get. So we still have 7 on the left side. On the right side, 2 times negative 3 is negative 6. Negative 6 plus 1 I actually think is negative 5. And so you'll notice here that these two are not equal. When we substitute negative 3 into our equation, the answer we got, we worked this on the right side, was actually negative 5, not 7. And so this point is not on the equation, or not generated from the equation. We'll try a couple more. Y equals 2, we'll just skip right to this. 2 times 0 plus 1, we'll just work with the right side. 0 plus 1, this gives us an output of 1. And so we have proved, or we have found, that when you input 0, you get an output of 1. And that does match our point. Last one, 1/2 comma 2. We'll replace the x with 1/2. Half of 2 is 1, and 1 plus 1 is 2. When we substitute in 1/2, we got an output of 2. All right, well, we found that 3 out of these 4 points are generated from the equation. So the question we should ask then is, what would happen if we graphed these 3 points? Well, it turns out that every equation we study this semester, including this equation up here with an input and output, is going to create a linear graph, which means if I were to graph this equation, it would show me a line. Why does it show me a line though? It shows me a line because we're taking each point here, and I'm going to show this over on the side. You do not need to write this. We had the point 3, comma 7. We'll have to write small here. Okay, 3, comma 7. That was 1 point. We had the point 0, comma 1, and the point over 1/2 up 2. And you'll notice that if you were to connect these points, they should, if I did my job well, lie in a line. Every point that works or is created from this equation will fall on this green line. For example, if I had this as an input of 2, this point right here, 2 comma something, will come from putting 2 into the equation, finding the output, and that will match this piece over here, right? 1, 2, 3, 4, 5. I think if I substitute 2 in here, I do get 5. All right, so an equation then generates an infinite number of points. And this semester, at least, when you put all of those points on a graph, it makes a line. Our goal for today, then, is to figure out what do these lines look like, and is there a fast way to graph them? So let's go ahead and take a peek at problem 2. Find the slope of each line without using the slope formula. Well, we learned last class that our slope is always a rise over a run, and we actually covered how to do this. This should be a nice review, right? You could go through and you could try these on your own, I think. But as a friendly reminder, what we did last class is we found nice integer points on here. We found 2 of them. And this isn't going to be perfect. These graphs are a little bit hard to read. I'm picking the best points I can, though. I think these 3. And then we looked at the rise over the run. When we go through and we do that rise over the run, I like to find the rise first. Pick any point. I'm going to pick this point right here and this one down here, and we find the rise first. So I'm going to rise 1, 2, 3. And it's kind of weird to say rise 3 because we're going down. Because we go down the y-axis, the rise is -3. And then we have to run over to get to the point 1, 2, 3, 4. So we run over 4 and get a slope of -3/4. Don't forget that you can write that slope in 3 different ways. You can write it like that. You can write it as 3 divided by -4. Or you could write it as -3/4. All of those mean the same thing. It's totally up to you. Let's try the second one. 3 nice points. This is where things get a little weird. I think this is a pretty nice point. This one looks pretty good. And I think that one looks pretty good. Okay, let's try our rise over run. I'm going to start here. We have to rise up 2 and then run over 1, 2, 3, 4, 5. So we rose up 2, ran over 5. The other way you could have written this is if you went the other direction, you would have gone left 5 and down 2, and it would have been the same fraction, but it would have been -2 over -5, and 2 negatives make a positive. And our last one. Okay, let's find 2 nice points. Getting a little harder here. Maybe here. I don't know. And so what I've found in the past is that my students will pick points that they think are pretty close here. And that's okay. And I'll show you an example of this one in just a second. So this, we're going to do the rise down 1, 2, 3, 4. And then we've run over 1. So it looks to me like my slope is -4 over 1. But then if I go down 1, 2, 3, 4 over 1, that pretty much looks like it's matching up. But what if someone had said that they thought it was this point right here? Well, then my rise would have been 1, 2, 3, down 3, and over 1. So would they have gotten credit with down 3 over 1? Sure. I think a steepness of -4 compared to a steepness of -3 are pretty close. Unless someone's giving you the exact points on here, you probably don't have to be perfectly accurate on a graph. All right, let's go ahead and check out the next part. Now, we've been given the slope of a continuous line. What does a continuous line mean? A continuous line means a line that continues in each direction. We usually put arrows on the end to show that it goes forever. right? A continuous line. Sometimes you'll hear people say that a continuous equation is one where you never have to pick up your pencil to draw it. So if I were drawing a line and I picked up my pencil, that wouldn't be continuous anymore. There's a gap. But this guy over here is continuous. Okay? We're given both the slope, that's the m part, and also a single point on that line. Our goal is to graph 2 points in each direction from this point for a total of 5 points. Then connect them to create that continuous linear equation. All right, so problem 3. Let's see what we can do. We'll start with the point. -1 and then up 2. Then we need to use our rise, which is 1, up 1, and our run, which is positive, so right 2. So I'm going to rise up 1 and then run right 2, and hey look, I have another point. We can probably continue the rest of that too. Up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. And it said in each direction, so let's go. Let's see, back 2, down 1, back 2, down 1, back 2, down 1. We can see that same pattern all the way through. Doesn't that look like a nice linear relationship? And then we don't just leave them as points. We do actually need to connect all of these points. And the reason we need to connect them is, first, they told us it needs to be a continuous function. Individual points are not continuous. But second, we need to show that every point on this line is connected by a slope of up 1 over 2. Look, even if I didn't pick a nice point, if I picked this point in the middle, I could still go up approximately 1 and over 2, and I still end up on the line. All we need to create a line is a single point and a slope. And keep that in mind because we're going to come back to it a bunch today. A single point and a slope is enough to create a line. Let's try 2 more. 3, -4, right 1, 2, 3, down 1, 2, 3, 4. And our slope. Our slope's not a fraction. That's tough. Couldn't we just write that over 1 though? So then, and if I rewrite this over here, -2 means we rise down 2. And 1 means we run 1 to the right. Easy for me to say. Down 2 over 1. Sometimes students will say, well, I'm not sure if I'm supposed to go left or right. Well, if you had gone down 2 to the left 1, think about the shape of this line right here. Just thinking about the direction, does this line have a positive slope or a negative slope? I think most students can usually tell me if it's positive or negative. To me, this line is going up, so it has a positive slope. But that's wrong, because the slope over here is negative. So I know I went the wrong direction with my point, and I need to go down 2 to the right 1. And then we can finish this off. Up 2, left 1, up 2, left 1, and so on and so forth. And we connect to finish this off. A little curvy there. That's fine. All right, last one. We have the point -2, -1, and then our slope. Ooh, this negative is in the middle of the fraction. You can move it anywhere. I'm partial to putting the negative on the top of the fraction, and I like to do that because then if the bottom is positive, we always remember to run to the right. So I'm going to go down 2, right 3, down 2, right 1, 2, 3, and the same thing. Down 2, right 1, 2, 3, or up 2 to the left, 1, 2, 3, up 2 to the left, and I kind of ran out of space there. So that's about as good as that one's going to get. We will connect this. And then the last thing you should do as you're drawing these graphs is you should check yourself and say, well, I know that the slope is supposed to be negative. Is my graph going in a downwards or negative direction? It is. We'd say that this graph is decreasing. It has a negative slope. All right, moving on to this next page, we're going to go through and try to make a connection between equations on this page and what the graphs of those equations look like. So, we have the graphs of 4 lines shown, and I'm going to go ahead and kind of emphasize them in different colors just to make them stand out. Right? We have -2x minus 4, and I'll color code these over here so we can see what's happening. This guy kind of rolls down over here. Then we also have y equals 2x plus 3, which is supposed to be in, well, let's do it in green. That's the next color here. So here is 2x plus 3. It's this guy running up here. Pretty good. Next up is y equals 2x. And last but not least, y equals 1/2 x minus 2 is this guy who's sitting over here. Okay, what are we doing with these? Well, we are going to fill out this table. And to fill out this table, we need both the slope of the equation and the y-intercept. And don't forget, this is mentioned up above. The y-intercept is where a graph crosses or touches the y-axis. We can see the y-axis up here. And I'm just going to kind of put it down in red here. So if we're looking for the y-intercept of an equation, it's going to be where the line crosses this red axis. So let's tackle one of these together, maybe that y equals negative 2x minus 4 that I have in blue, and then you guys can see if you can determine the y-intercept and the slope of the other three. Alright, so negative 2x minus 4, let's do that slope first. Remember, we're going to need some nice points here, so I'm just kind of outlining those integer or nice points on this graph. I think it's probably easiest to calculate the slope here. Looks like it goes down 2 and to the right 1, yeah? So my slope is down 2 to the right 1, and I'll simplify that one too. Then we also need that y-intercept. Well, the y-intercept is where the blue graph crosses or intersects the red axis. And it looks like that occurs right down here at this point, negative 4. Now don't forget, the point negative 4 is not actually a point. A point has two parts. We know the y-coordinate is negative 4. It's on the y-axis. But where did we move on the x to get there? Well, we moved to an x of 0. So 0, negative 4 gives us the y-intercept. So why don't you go ahead and pause this video and then try those other three. If you finish early, work the two questions down below. You can unpause to make sure that you're right. Alright, so we have y equals 2x plus 3. That's the one I did in green. Let's take a look at the slope. Finding two nice points. I think this point and this one look pretty nice. Up to the right one. Looks like my slope is 2 over 1, which is 2. And what about that y-intercept? Where does green intersect red? This is the value 3. Okay, and so we know the y value is 3. The x value for a y-intercept is always 0. So I think we can actually fill that in for the rest of these. Okay. In yellow, y equals 2x. Let's find two nice points. I see 2 points right here. Looks like we go up to over 1, and actually that makes sense because if you look at the yellow and the green graphs, aren't they parallel? And we know parallel lines have the same slope here, don't they? And then what about the y-intercept? Well, it looks like this yellow graph crosses the red axis, I think, right at 0, doesn't it? This is the point 0, 0. Okay, so then moving through there, we can move on to our last one, which is y equals 1/2 x minus 2. When we go through and do that 1/2 x minus 2, we pick two nice points, maybe these two over here. We go up 1 over 2, up 1 over 2. Okay, that gives us, well, it is already simplified to 1/2, right? What about that y-intercept? Well, looks like we cross down here at negative 2, don't we? 0, negative 2. Alright, well, now that we have this filled out, let's look at these two questions, because these are actually two very important questions for the day. Part A says, describe the relationship between the written equation, and the written equations is this section right here, and the slope that we found on the graph. So I think maybe we should kind of compare equation to slope. We have this equation, this slope. Do we see any connections? Do the connections match here, and here, and here? And I think this connection is not super hard to make, is it? You might notice that in these equations, the number that is multiplying by x times x times x times x times x is actually the same as the slope that we found on the graph. So if we had something like y equals, what do we call the slope? The slope is called m, isn't it? M is multiplying times x, and then there's some number that's adding, or we could also say we have some number that's subtracting at the end. The number that's multiplying by x, right? So the number that is multiplying by x is the slope. And in fact, if our equation matches this format where y is on the left side by itself, and then we have a number multiplying by x on the other side, then that is always going to be the case. The number multiplying by x is our slope. It tells us the steepness of the graph. And that's actually an awesomely cool shortcut if we want to graph this equation, and we'll see this later on. All right, second part. Describe the relationship between the written equations, that first column again, and the y-intercept we found. Well, kind of erasing these and going through, let's take a look. Here are our y-intercepts in red. Okay, and then do we see those in the equation? Well, -4, I see that. +3, that looks good. -2, I see, but this one says 0. I don't see a 0 here, but wait, you probably are saying, oh, I remember this. We know that we can always add or subtract a 0 at the end, and that doesn't change anything. If you have $10 and I add 0 to it, you still have $10, so we can always put a +0. And yeah, that is our other connection. So if we had these two maybe general equations over here, it seems like the number that's adding or subtracting to x, so the number that adds or subtracts to x is the y-intercept. And if the equation does look like this, then you are 100% right. That number will be the y-intercept every time. You might remember that on this previous page I mentioned that in order to create a line, you need a point and a slope. And in fact, this equation right here has a point in it. It has the y-intercept and it has the slope. Now, let's say that we didn't know that shortcut. Because when you first learn how to graph anything, your teacher doesn't show you shortcuts. They make you graph an equation using a table. And it's a really important skill. You should be able to build any graph or any table with an equation. And the way it works is just like what we did on the opener, with an input and an output. Okay, so I have this equation y equals 1/2 x minus 4. We're going to include 5 x values. 2 negative ones, let's put those in, 2 positive ones, and of course 0. So let's make sure we know what we're doing first. Let's just try 0. 0 is an input here, right? This is going to make 0 comma something. To find the output, we replace the x with 0, and we subtract 4. Okay, and then if you wanted to do just a little mental math here, it's not too bad, right? Half of 0 is 0, and 0 minus 4 is -4. So when we input 0 into my equation up here and did the math, the output is -4. Okay, now we can use any numbers we want in this table. It doesn't matter. We could use 1,000,000, 7, -500,000, but since our graph only goes to really -6 on all sides, or 6 on all sides, then we probably don't want to use huge numbers. Also, because we're taking half of a number every time, I think even numbers is a good idea, because half of an even number, right, if you do half of 6, that's 3. But if you do half of an odd number, half of 3 is 1.5. And decimals on graphs are okay, but they're not great. So let's use some even numbers that fall on the graph. On the negative side, maybe -2 and -4. On the positive side, maybe 2 and 4. Remember to find the y values, and I'll just use the positive numbers first. We just take this and substitute it in. And now we're going to do some mental math. Half of 2 is 1. 1 minus 4 is -3. Let's use 4. Half of 4 is 2. 2 minus 4 is -2. Okay. Let's try the other side. Half of -2 is -1. -1 minus 4 is -5. In fact, looking at this table, I bet you can see that this one's going to be -6. Can you see the pattern? Math is all about patterns. Let's check it though. Half of -4 is -2. -2 minus 4 is -6. Cool. Well, now that we have a table, right, we created this table by using inputs and outputs, okay, we can go through and we can graph all of these points. I'm going to rewrite these points, x, comma, y, x, comma, y, and so on and so forth. And I'm just doing this just so you can see when I graph where all my 5 points, I have 5 points here, come from. -4, -6 is right here. -2, -5, 0, negative 4. I think we can finish the rest off, right? This one's going to be 2, negative 3, and 4, negative 2. First thing we want to check, do these 5 points lie in a straight line? And I think they do. It does look like they are in a straight line, which is good because we're dealing with linear equations. Next thing we want to do is realize that we picked 5 points, but this is going to be a continuous linear function. All of our graphs are going to be this year, so I do need to go through and connect these 5 points to see that continuous linear function. Now that we're here, let's go ahead and fill in the last 2 pieces. B, compare the equation of the line y and the y-intercept. What do you notice? Well, let's see, the y-intercept, we can see this on the graph, the y-intercept is negative 4. If we compare y equals 1/2 x minus 4 versus the y-intercept of negative 4, do they match? And I think they do. There's a negative 4 here and a negative 4 over here. We also had seen that up above where the y-intercepts matched the number that was adding or subtracting. Okay, well, last but not least, find the slope of the line that you graphed. Okay, well, that's a rise over run. We have to rise up 1 and run over 2. So my slope of the line is 1/2. Let's compare our equation, which is 1/2 x, again, minus 4. Well, do we see something in common? We do. The number that's multiplying by x is the slope. So hopefully at this time you're pretty convinced that if we get an equation where there's a number multiplying by x and then a number adding or subtracting, we know quite a lot about the equation. We know both the slope and the y-intercept. So let's go ahead and summarize this and then see how we can use it. Alright, so now let's go ahead and take a peek at a new equation, one that we haven't seen the graph of, we haven't made a table for, and let's see if we can determine anything from this equation. We're going to look at the equation y equals negative 3x plus 2. Just by looking at the equation, no graph here, no table, can we tell what the slope is? Well, hopefully you said, yeah, the slope is negative, and I should write this over here, is negative 3, or as a fraction, you can write this over 1, negative 3 over 1. And I know this because negative 3 is multiplying by x. Let's try another. The y-intercept of this equation, well, I think that one has to be 2. You could write it as a point, 0, 2. And we know that because 2 is adding to x. Remember, the number that adds or subtracts seems to be the y-intercept every time. So now that we know the connection between these two, between the equation and their slope and their y-intercept, I bet we can go through and graph these equations really fast just using our 2 shortcuts. So let's take a look. Y equals negative 3x plus 2. Negative 3 is multiplying by x, so I know that the slope is negative 3. Then we always write that as a fraction, so negative 3 over 1. That means rise down 1, rise down 3, run to the right 1. And I also know the y-intercept. The y-intercept is the number adding, the y-intercept is 2. Or if you want, it's the point 0, 2. So to graph this, we start with the point 0, 2, which is right here. And then we use our slope. Our slope says to go down 1, 2, 3, and then to the right 1, and this will give us another point. And continue out, down 1, 2, 3 to the right 1. Or we could go the other way. I can go up 3 to the left 1, up 3, left 1, up 1, 2, 3 to the left 1. Do all these points fall in a line? They do. Do they have a negative slope? They do. So let's connect them and call it good. Here's my line. That was not a good line. We're trying again. That one was a little bit better. There we go. And we were able to graph the linear equation y equals negative 3x plus 2 without too much trouble. Let's try one more. Okay, we know that the slope at this point is multiplying by x. What number in here is multiplying by x? I think I think 2/5 is multiplying by x. So in this case, my slope is 2/5. What number is adding or subtracting to x? And sometimes it can kind of be tough to see it this way. So actually, I'm going to rewrite this equation. I like to put the slope with x first. Let's put the other number at the end. This negative 3, if you move it to the end, just becomes a minus 3. And now can we see the number that's adding or subtracting to x? Well, hopefully, you can note that the number is negative 3, or it's the point 0, negative 3. So let's go ahead and graph that. 0, negative 1, 2, 3 is right here. And then our slope. Our slope tells us to go up 2 to the right 5, up 2, 1, 2, 3, 4, 5. Or I could go the other way, left 5, down 2, continuing the pattern, 1, 2, 3, 4, 5, down 2. And we can connect these to go ahead and make our line. So hopefully this isn't too terrible, right? We're just using two parts of our equation, the slope and the y-intercept, and graphing. In fact, we need a quick conclusion here, and then you guys can get some practice in. Traditionally, our equation is written as y equals mx plus b. You should note that the m is multiplying times x, and the b, of course, is adding to x. This is known as slope-intercept form, and you do need to know that name. We should know at this point what m represents, right? M in this equation is, of course, the slope. And at the same time, we should know what b represents. Even though we haven't quite talked about it yet, we know at least what b has represented up here. B is the number adding or subtracting to x. Each time over here, b has represented the y-intercept. So, why is the equation y equals mx plus b known as slope-intercept form? Well, never forget, mathematicians are not very creative. It's known as slope-intercept form because this equation gives you the slope, that's right here, and y-intercept, that's right here. INT is a very common abbreviation for intercept. Well, any idea why they use b here? Because b certainly doesn't stand for y. Well, they can't use y again because y is already in the equation. That would get confusing. So I like to tell my students that b is the y-intercept, but I say that b stands for the beginning because it's where we began our graph every time, right? Our b up here was negative 3, and we began at negative 3 on the y-axis. Our b here was 2. We began at 2 on the y-axis. So how do we graph equations in slope-intercept form? Well, there's only two steps. Step 1 is we start at b, which is, of course, the y-intercept. And then step 2 is once you have graphed one point, you use m, which is, of course, the slope, to create more points. That's it, right? We use one number, the y-intercept, that's our starting point. We use m to move or to create more points. And that's it. So, why don't you guys go ahead and try one of these on your own, and then we'll talk about what we're doing for the rest of class. Ready, set, go. Oh, you're back so soon? You needed a hint? Well, hint-wise, we want to make sure that y equals negative x actually fits the form y equals mx plus b. So let's take a look at that. I'm actually just going to write it directly underneath. Y equals, that's good. There's a negative and an x. But I think we're missing all the numbers. But we know if there's no number written in front of x, we can always put a 1 here. So I think our m, our slope, is negative 1. Then we also need a b. Our b value, though, I think is just plus 0. We can always add or subtract 0. That's something a lot of students confuse. They think, well, when can I put a 1? When can I put a 0? But if you think about a real-life situation, we're allowed to write in these numbers when it doesn't change the problem. So think to yourself, if you have $10, can you add 1 or multiply by 1 to keep your money the same? Well, 10 times 1 keeps it the same 10, so you can multiply by 1 and not change it. 10 plus 1 makes it 11, and that does change your money. And we're not trying to change the equation. We're just trying to put numbers in that don't change it but give us a different perspective. So you're always allowed to multiply by 1, add 0. This tells us then that m is negative 1 and b is 0. All right, well, let's move on to part B. Part B says, identify the slope and y-intercept of your equation. Well, we actually did that because the slope is m, though we do like to write slope as a fraction, so negative 1 over 1. And the y-intercept is b. All right, b is 0. We know for a y-intercept the x is always 0, but the y is 0 here too. Let's go ahead and graph our equation on the right. We have our beginning point, 0, 0, and then our slope, which tells us to move down 1 to the right 1. So over here, I'm going to go down 1, right 1, and that will give me another point. Down 1, right 1. You could go the other way, up 1, left 1, up 1, left 1. Here we have a few more points, but remember we're graphing continuous lines, not individual points, so we do need to go through and actually connect all those points to make our line, and it looks like that. Ta-da! All right, moving on to our last page for today. We discussed how to graph equations in slope-intercept form. Slope-intercept form equations are going to make diagonal lines, either with a negative slope like this guy or a positive slope like this one. But last class we discussed that there's two other types of slopes we need to be comfortable with. Slopes of 0 and undefined slopes. So what we're going to look at on this last page is how to graph, okay, and we're going to put this in here, how to graph 0 slopes and undefined slopes. As a reminder, a 0 slope is a line with no steepness. It goes straight across. That was not awesome. There we go. And an undefined slope is one that's so steep we can't put a number to its steepness. So let's go ahead and practice. I'm going to do this first column, and I think you guys should try the second column working along with me. I will go back through it, but it's going to be easier if you do it with me. All right, the first thing we need to do is graph 4 points below that are in a horizontal line. Well, it doesn't matter what spot you pick. I'll go ahead and pick, I don't know, positive 3. So I'm going to put 4 points in a horizontal line over here. So here's 1, here's another, another, and another. You can put them anywhere you want as long as when you connect them, and I'm going to do that right now, they make a horizontal line. And that was not a great line. I want to try again. So pick your 4 points. You can do the same ones I did or a different one, up to you. And then it did ask us to list the 4 points in XY form below. So my first point is over here. That is left 4 and up 3. My next point is negative 1 and then up 3. My third is 0 and then up 3. And my last was way over here. It is over 5 and then up 3. Looking at those 4 points, what do they all have in common? Well, it looks to me that each of them has a y that's equal to 3. Right? There's no pattern to the x's, but the y seems to have to be 3 here. Okay? Well, if that's the case, what do you think the equation of the line is? Oh, well, the equation of the line is that easy. It is just y equals 3. Seriously, that's it. Now, you'll notice that y equals 3 is kind of weird because it doesn't fit our slope-intercept form. Slope-intercept form had a y and an x. And whenever you have both of those, you're going to have a diagonal line. But if you just have one of them, I just have y here, I don't have x, it's either going to be horizontal or vertical. So here is our horizontal line, and that's it. It's just y equals 3. There is no x. And that's because in our points, the y has to be 3 every time. The x can be anything you want. So our equation doesn't depend on x. It's just telling you y always has to be 3. Let's look at D. Find the slope between 2 different points on your graph. What's the decimal equivalent of that slope? Well, let's just pick my first 2 points. I'm going to do these guys right here. This is a nice reminder of your slope formula, right? So I have, and we'll need some space, negative 4, 3, and negative 1, 3, x1, y1, x2, y2. Let's find that slope, right? 2 sets of parentheses like so. We have y2 minus y1 over x2 minus x1. 3 minus 3 is 0. Negative 1, this turns into a plus 4, is 3. I get the slope that has a rise of up 0 and a run of over 3. If you try that on your calculator, though, 0 divided by 3, you will get 0. And in fact, that shouldn't surprise you. We discussed it last class. The slope of any horizontal line is 0. And that is because there is 0 steepness to your line. What is the generic form of any horizontal line that will pass through the point A, comma B? Well, if A is an x and B is a y, and we know it's on our horizontal line, horizontal always means y, and it's going to pass through whatever y coordinate is here, right? Didn't it pass through each of these y coordinates? So it would just be y equals whatever the y coordinate is. And that's it. That's how easy our line is. Now hopefully you were following along and trying this with the vertical line as well, but if you didn't, I told you I would go back through it, so let's do it right now. I'll go ahead and pick, let's see, where's I'm going to make my vertical line. I'll do it in -2. I'll do this one, this one, this one, this one, and this one. It said 4 points? Oh, 4 points. Whoops. All right, those ones. Let's see, 4 feels left out. We'll do that. Great. Here is my vertical line. I listed 4 points, or I put 4 points, list the coordinates. I'll start at the top. That is over 2, up 3. This next one is over 2, up 2, to -2, comma 0, and the last one is -2, comma -4. Okay, what do all of those have in common? Well, it looks to me that each of these points all have an x that's equal to -2. Based on your results above, what do you think the equation of that vertical line is? Oh, you're right. The equation is x equals -2. Right? Just like the other one. When we had y, you'll notice that our horizontal line went through the y-axis. When you have x, our line goes through the x-axis. All right, well, let's find the slope between two different points on our graph. I'll go ahead and take the first two again, just like I did before. You can choose any one. You'll get the same answer. So we should probably write those points out first. We have -2, 3, and -2, 2, x1, y1, x2, y2. And here's our slope. 2 sets of parentheses, subtracting on the top and bottom. Numerator, let's see, y sub 2 is 2, minus y sub 1 is 3. Okay, and then the other, we have x sub 2 is -2, x sub 1 is -2. 2 minus 3 is -1. -2 plus 2 is 0. If you try this on your calculator will either tell you error, divide by 0, or something else. Well, looking at this, we always like to just say, and it's not really equal because it's not a number, we'd probably just say undefined. Sometimes that's fancy math people will put DNE, which means does not exist. That's totally fine. All right, well, what is the slope of any vertical line? The slope of any vertical line is undefined. Why is it undefined? Well, it's straight up and down, so we don't have a measure of that steepness. So we say can't measure the steepness. What is the generic form of any vertical line that passes through this point? Well, if you were given this and said, I want a vertical line that goes through that point, it would just be x equals -2. It's the x coordinate. X equals, in this case, the x coordinate is a. All right, finishing this off. Let's do 2 practices. Graph each equation given below. X equals -1. Well, what I like to do with this, because I have some students that forget, is I actually create a couple points. So I go through, here are 4 points. What do I know about these points? I know the x must be -1. Is there any y in this equation? Well, no. That means that our y can be anything we want. I'll just pick 1, 2, 3, 4. We could have done negatives. Then, graph these points. -1, comma 1, -1, comma 2, comma 3, comma 4. Can we see the vertical line that's being created? I hope so. This is the line x equals -1. Same thing. Y equals 3, which somewhat sadly is the one that I did up above, but that's okay, we'll make 4 points. Doesn't matter what they are. And for each of these points, the y has to be 3. Is there any x here? No. So pick whatever x's you would like. I don't know, we'll do some negatives. They feel neglected. So I have the point 0, 3, negative 1, 3, negative 2, 3, negative 3, 3. Can you see the horizontal line that is taking form? And there we go. So what do we need to be able to do today? Well, there's really 2 main concepts. First, if I give you, and I should have done this up above, if I give you an equation in slope-intercept form, you need to be able to graph it by identifying the y-intercept and the slope. Second, if I give you an equation in the form of x equals something or y equals something, you need to be able to graph either a vertical or a horizontal line. Thanks for tuning in today to learn about slope-intercept form and then our horizontal and vertical lines. I'm excited to come back to you next class with our different form of a line called HK form.